In 2016, inside a hospital in Estonia, a team of doctors sat down to do something completely ordinary. They were monitoring the brain of an elderly patient, an 87-year-old man who had recently been treated for a bad fall and was now suffering from epilepsy. The plan was simple. They wanted to watch his brain during a seizure so they could understand the electrical storms that kept sweeping through it. Nobody expected anything historic to happen. Then, in the middle of the recording, the man's heart suddenly stopped, and he died right there while the machine was still running. By pure accident, those doctors had just captured something no scientist had ever recorded before. They had a continuous scan of a human brain in the exact moments it crossed from life into death, and what that scan showed has quietly reshaped the way we think about dying. In this video, we are going to walk through what the machines actually recorded, how the brain even produces the signals we measure, why researchers reached the conclusion they did, and what all of this might mean for that old idea that your life flashes before your eyes at the end. I want to take this slowly because the details matter more than the headline. Let me start with the recording itself. The device they were using measures electrical activity, and in total they captured about 900 seconds of the man's brain, a full 15 minutes surrounding the moment his heart gave out. What caught everyone's attention was a specific window, roughly 30 seconds before the heart stopped and 30 seconds after. In that narrow band of time, the pattern the brain produced looked strikingly like the patterns we see when a healthy person is remembering something, meditating, or dreaming. That is an astonishing thing to sit with. The organ was shutting down, oxygen was vanishing, and yet its final rhythm resembled the rhythm of a mind actively pulling up memories. It suggests, at least tentatively, that the old cliché might carry a grain of truth. A dying brain may genuinely be replaying pieces of a life. To understand why that is such a big deal, you have to understand how we read the brain in the first place. When people talk about brain waves, what they really mean are oscillations, rhythmic pulses created by huge groups of neurons firing together in loose coordination. We have known these waves exist for nearly a century, and yet we still do not fully grasp everything they do. Scientists sort them into a handful of families based on how fast they cycle, and each family tends to show up during a different mental state. If you learn to recognize them, they become a kind of language the brain speaks about itself. Alpha waves cycle somewhere between 8 and 12 times a second. You see them when a person is awake but calm, eyes may be closed, relaxed but not asleep. They tend to appear during creative thought and gentle coordination, and they fade as drowsiness sets in. Beta waves are quicker, roughly 12 to 30 cycles a second, and they dominate ordinary alert life. When you are focused, busy, thinking hard, or gripped by anxiety, beta is doing the heavy lifting. Then there are gamma waves, the fastest of the group, ranging from about 25 all the way up past 100 cycles a second. Gamma is tied to the high end of mental work, things like attention, working memory, and mood. It spikes when you are intensely concentrated, and interestingly, it can be strengthened through meditation. There is one particular frequency inside the gamma band, right around 40 cycles a second, that researchers find genuinely fascinating because it seems bound up with clarity, awareness, and the very sense of being conscious of your surroundings. In a real way, gamma sits close to the machinery of consciousness itself. The slower waves matter too. Delta waves are large and lazy, cycling only about half a time to 4 times a second, and they belong to deep, dreamless sleep. That is when the body quietly releases hormones that repair and maintain us. Theta waves sit in between, around 4 to 7 cycles a second, and they show up during memory formation, learning, and the brain's efforts to map where we are in space. Like gamma, theta can be deepened by meditation, so already you can see a picture forming. Some of these rhythms are the signatures of remembering, of reflection, of the inward turn we make when we dream or meditate. Now bring that knowledge back to the dying man. When the researchers examined that critical minute around his death, they did not just see random noise, the electrical flailing you might expect from a failing organ. They saw a surge of gamma activity in exactly the frequency range associated with pulling memories out of storage. In a living, healthy brain, when you reach into your past and retrieve a moment, gamma flares in this way. And here it was, flaring in a brain whose owner was, by any medical definition, dying. Other scientists had glimpsed pieces of dying brains before, but never a complete, uninterrupted recording like this one. This was the first time anyone could watch the whole arc, and the arc pointed toward memory. This is where science brushes up against something older and stranger, the near-death experience. For as long as people have been resuscitated, they have come back telling remarkably similar stories. A tunnel of light, a sense of peace, and very often the feeling of their entire life unspooling in front of them in vivid detail. These are not the reports of one or two unusual individuals. They turn up again and again across cultures, across ages, from people pulled back after cardiac arrest, and even from women who nearly died giving birth. The tunnel vision may have a physical explanation, since a dying brain begins pulling blood away and rerouting it toward the organs it is desperate to protect. But the life review, the flood of memory, has always been harder to pin down. Now, for the first time, there was a brain scan that seemed to hum along in step with those accounts. I do want to be honest and careful here because the researchers themselves were. This is a single patient and his situation was complicated. He had suffered bleeding in the brain and repeated seizures, and both of those things distort the normal rhythms we rely on to interpret a scan. When a brain loses its oxygen supply, its cells can fire in a strange final burst of activity that produces its own patterns, which muddies the picture further. On top of that, the man was taking several medications, any of which could nudge his brain signals in unexpected directions, either directly or through their effects on the rest of his body. And crucially, because he was being scanned to study a seizure and not to study death, there was no clean baseline of his ordinary brain to compare against. So we cannot treat this as settled proof. It is a single, accidental, deeply suggestive data point. There is one more twist worth mentioning. This event happened back in 2016, yet the findings were not published for 6 full years. The reason is telling. The scientists wanted to replicate the result before they announced it. They wanted a second dying brain scan to confirm the first. But capturing something like this requires a person to die unexpectedly in the exact instant their brain is already wired up and recording. And that is an almost impossible thing to arrange on purpose. So they waited, and they were never able to catch that lightning again. In the end, they published the one recording they had, framed honestly with all its limits laid out. Still, it does not stand entirely alone. Controlled laboratory studies in rodents have shown surprisingly similar bursts of activity in dying brains, which means the human recording lines up with a pattern we can observe in a more careful setting. When two very different kinds of evidence point the same direction, it is hard to dismiss. Taken together, all of this hints at something both humbling and strangely comforting. It suggests that when the body finally lets go, the brain may not simply flicker out into darkness. It may light up one last time, reaching back through the years and gathering the moments that mattered most. If that is true, then perhaps the old saying was never just a myth. Perhaps in our final seconds, we are given a quiet gift, a chance to relive our brightest memories, a last soft glow before the lights go down for good.